Alright, today I'm going to cover the ed puzzle, which is going to be on similarity. So our new unit that we're going to be talking about today is on similarity of polygons and triangles. If you haven't finished the map testing, you should have had email directions about finishing up that map testing outside of class. Okay, each day you should be able to get a link, and I don't know if the Google Meet will be different every day. Okay, but you should be able to get a link to finish up that map testing and see the directions that I did send out on email. Okay, when you are finished with this ed puzzle, okay, you can do problems 12 and 13 from section 12.2. If you haven't already done so, 12.1, the assignment was 1, 2, 9 through 15 all. Okay, and those can be done previous to this lesson. All right. Okay, what we're talking about today is dealing with ratios and portions, and as you found out from the section 12.1, if I told you if there were 14 girls, okay, in this classroom, and 8 boys, and Beal's classroom across the hallway, okay, has 24 students in all, and I want to know how many girls there are in Beal's class. I should be able to set up a proportion, okay, and that proportion right here is going to be, okay, my number of girls that I have in my class, okay, over the total, okay, students that are in my class, and set that equal to, okay, Beal's class, okay, Beal's number of girls that he has in his class over, okay, the total that are in Beal's class. Okay, and when you're doing this, I don't want any decimal answers in this unit. Okay, similarity is all about fractions and proportions. Okay, we haven't done any decimals anyway, so it shouldn't be too new. Okay, what I'm expecting of you. So I have 14 out of, okay, there's going to be a total, okay, of 22 students, okay, that are in this class. And if Beal, okay, has 24 students in his class, okay, I want to know X number of girls. So I cross multiply, okay, and, okay, multiply here out, okay, 24 times 14, looks like 24 times 14 is 336. Divide by 22. Okay, and I know I'm going to get a fractional answer here. Okay, and I know that right there can be written. You can reduce this down all you want. I don't care if you leave it. In this case, it's an application problem, okay, here. So if you just left it as an improper fraction, it probably, you wouldn't really be able to know, since it's an application, how many people that really is. Okay, 168 over 11 number of girls. Okay, but if I take that and divide that answer divided by 11, okay, we know we're going to find out there's going to be about, okay, 15. Okay, so I would say 15, and then you're going to have 3 11s. Now you can't have a partial girl. Okay. Now, if we were talking about boys, okay, then I usually pick on, you know, some of our boys there. And Griff, you could have been the 3 11s boy that would have been in the class, but, or maybe you're the 8th, 11th of the boy that's left over, okay, that is in the boys. Since if there's 15 and 3 11s girls, okay, maybe you're over in Mr. Beal's class, Griff, and I would say then you're going to have 8 and 8 11s boys left over, and Griff, you'll count as the 8 and 11s of a boy. Okay, there's your shout out, Griff. So there you go. All right. So, going on here, okay, we're going to be talking about are these polygons similar or not? And obviously, if we're polygons to be similar, they have to have the same number of sides. Okay, if two polygons right up here, one's a triangle and one's a square, okay, no, they're not going to be similar. They have to have the same number of sides. Okay, now, are these polygons right up here similar to one another? Now, anytime that you're looking at any type of polygon, okay, now triangles eventually we're going to get some shortcuts to. But if you're comparing quadrilaterals or hexagons or heptagons or dodecagons, there's two rules, okay, that you have to have, okay, in order to prove, okay, polygons, okay, are similar or not. So these are the rules right here that you're going to want to write down, okay, in your notes. Okay, in order for polygons to be similar, both of these things have to be true. One, all angles, okay, have to be congruent. That is a must. They must all be, always look at the angles first. That's the easiest thing to find out. And then if all the angles are the same, and you can look down here right away, and we don't know if these angles right here, so you're going to say right away, no, okay, because angles are not equal. Okay, but if I was to come up here and I was to say, oh yeah, that angle right there is equal to that angle right there, and this angle right here is equal to that one, and part one's fulfilled, then there's a second part. Okay, and the second part is all sides, okay, must be proportional. Okay, you have to have, okay, both of these things have to be true up here. And I didn't have any markings for links in the sides. Okay, so in this one right up here, it still would have been a no, even if I marked those up there, it would have been no because the sides aren't proportional. Okay, so if I come over here and I look at my next example, okay, that I have right up here, okay, and I said, are these polygons going to be similar or not? Okay, well, number one, okay, are all the sides, okay, or so are all the angles congruent? Well, look at that. Whoops, I didn't mean to do that. I thought I had my marker. Okay, well, all these angles right here are going to be equal because they are 90 degrees. So we're good there on that rule. Okay, all the angles are going to be equal. But are the sides proportional to one another? Now, you can't just come up here and say, nope, because I don't think so. Because one's 3 times as much and the other one's not 3 times as much. This is how I want you to show if they're proportional. I want you to take and put a proportion between the sides. I got the small side that corresponds to the 6 side, and I'm going to put the 4 corresponding to the 7. And even though many of you guys can look at that math and say, no, they're not the same fractions, this is how I want you to mathematically prove it. Okay, I want you to take the cross product. 2 times 7, is that equal to 6 times 4? Okay, does 14 equal 24? And you got right there, that is a no. And so therefore, are these polygons similar to one another? And you would say no, because, you got to say why or why not, sides are not proportional. Now, if I'm ever going too fast on this Ed puzzle, remember, unlike in class, you can't pause me. Okay, so Ed puzzles are nice. When you can pause, you can rewind. Okay, all you want. Okay, the bad part about an Ed puzzle, you can't ask questions. Okay, hopefully any questions you have, circle them, highlight them, and ask those to me tomorrow. Okay, are these polygons similar or not? Go ahead and hit pause and tell me why or why not verbally out loud right now. Good, I heard you shouting at your computer right now, because this is what I hope you didn't do. I hope you didn't come up here and test the sides. Because why test the sides when you can say no right away? Because the angles, whoops, are not congruent. I didn't mark anything up there. I don't care how pretty they look. If I have to come up here and I have to mark all these angles. Now, if I come up here and mark all these angles are equal like I'm doing right now, then you have to come up here to step 2. Then you got to see, is this side and this side, are they proportional to one another compared to that side and that side right there? 3 over 9, cross multiply. 2 times 9 equals 6 times 3. I got 18 equals 18. Now that's not good enough yet because I still have, okay, this 5 and this 20. Okay, how about if I do 2 over 6? And I always want to keep one ratio the same. Okay, 2 over 6 equals 5 over 20. And then I still have the 2 over 6 equals, okay, well, I guess 2 over 6 is going to equal 2 over 6. That's a very easy given. Okay, but this last one right here, if I multiply it across, 2 times 20 equals 6 times 5. So even if I would have given you, okay, that the sides or the angles were equal, this right here would have said they're not equal. The sides aren't even proportional. But all you need is one of these. And once you have one of these, okay, that's going to be good enough to prove the polygons are not similar. When we get to triangles, there'll be shortcuts. Okay, but for right now, okay, we look up here and we say, okay, right away, okay, all angles, okay, are equal. We're good there. Okay, equal or congruent. Okay, second step that we have, are the sides proportional? I have no clue. There's no numbers over here. Okay, so this one right over here again is a no. Okay, because sides are not proportional. You have to have both, okay, to prove, okay, polygons are proportional. Okay, now, if I come over here and I tell you, here's the little similar symbol, okay, kind of looks like when you have the congruent symbol, the little squiggly line, okay, that's up there above it. Okay, and this is saying the first hexagon, A, B, C, D, E, F, is similar to hexagon WSRZYQ. Now, if they are similar, what I automatically know is all the angles are the same. Because I know similar polygons, all angles are equal. So I can come up here and I can mark all of these angles, okay, equal, okay, all the way around. Okay, right here, this is kind of getting boring to do this, but there we go, putting all that, because, okay, this all was similar. That rule right there said that they were similar. But the other thing that's true is that the sides are going to be proportional to one another. So if I have proportionality, that means 2 has to be proportional to x as 3 is proportional to 4. Cross multiply. Okay, and I come up with 3x equals 2 times 4. 3x equals 8. So it looks like, okay, my missing side is going to be 8/3, which is the same as 2 2/3. Okay, now that's if they are similar. That's the only time you can come up here and set a proportion up is if I give it to you, or the book or the worksheet gives that to you. Okay, now, what a pain in the butt. Having to do all of the sides, all of the angles for all of these polygons right here. Okay, what I wish is there was a shortcut. Well, for polygons, there's no shortcut. Okay, but, I mean polygons, okay, meaning quadrilaterals, heptagons, hexagons. But there are shortcuts, very similar to like when you had shortcuts when you're proving triangles congruent. Okay, remember we had the SSS conjecture, we had SAS conjecture, okay, we had angle, side conjecture, okay, we had angle, side, angle conjecture, angle, no, that one didn't work. Okay, and I am missing one right up here that I should have. I have, oh yeah, the one that, oh yeah, that one didn't work either. Bad word. Okay, those didn't work in congruency. What I'm curious about is which one of these, okay, is going to work, okay, when we're talking about similarity. Okay, and there are shortcuts that if you have these things right here, you don't have to get all the sides, you don't have to get all the angles equal, okay, but instead, okay, you can come up here and still prove, okay, that these polygons, these triangles, now these are only when you have triangles, okay, when you have triangles, okay, you're going to be able to come up here and prove these triangles are similar. Okay? When you have polygons, you got to get all the sides, you got to get all the angles. Okay, I have a little video here for you.
Section A, proving the similarity of triangles.
Uh-oh, it's on the wrong screen.
The similarity stuff. There are three properties we'll use to prove that two triangles are similar. We have the angle-angle similarity postulate,
Hopefully you can see this.
side-angle-side similarity theorem, and the side-side-side similarity theorem.
The angle-angle postulate, side-angle-side theorem, and side-side-side theorem are a lot like the other theorems we use to prove triangles congruent. We can still divide polygons into triangles and use the similarity postulates like we did with the congruent postulates. But remember that these are for similar triangles, not congruent triangles. Let's take a look at our new postulate and theorems and solve a few examples with them.
The angle-angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar.
So let's say we have triangle A and triangle B. They both have angles that measure 45 degrees and 55 degrees. By the angle-angle similarity postulate, we can say they're similar. Not congruent, but similar.
Next, we have the side-angle-side similarity theorem, which says that if one angle of one triangle is congruent to one angle of another triangle, and the sides that form the angles are in proportion, not congruent, but in proportion, then the triangles are similar.
So for triangles A and B here, we state their similarity because they both have an angle of 55 degrees, and the measures of the sides that form the angle are in proportion. See, our ratios are 2/4 and 3/6. We cross-multiply for 12 equals 12, so the sides are in proportion. According to the side-angle-side similarity theorem, our triangles are similar.
Our last theorem is the side-side-side similarity theorem. The side-side-side similarity theorem is similar to the example we just showed you a minute ago. It says that if the sides of two triangles are in proportion, then the triangles are similar.
So for triangles C and D, we set up ratios. We'll start with the two shorter legs. In triangle C, we have 4/6. We set 4/6 equal to triangle D's smaller sides, 5/7.5. We cross-multiply for 30 equals 30. So the two sides are in proportion. We still need to check the long side, so we'll set it over one of the other sides. It doesn't matter which side we choose. Let's go with the shorter side. We'll set our ratio as the long side over the short side. Triangle C's ratio is 7/4. This is the set equal to triangle D's 8.75/5. Now we cross-multiply for 4 times 8.75.
It's not the best way I like writing the proportion on this one. I would not write down that note.
The side-side-side similarity theorem.
The sides still all have to be in proportion, but I don't like how they put the proportion up there. Alright. So, okay, I know some of you are wondering, oh, don't go, I want to read all the PDITs. Then hit pause right now. Okay, you can hit pause and read it. So what I told you right up here is there's actually, of all of these right here, when we're doing similarity, all of those rules right up there are actually still going to work. The ones that work for similarity are also going, or congruency are also going to work for similarity. We had SSS, but you got to put the word, okay, similarity after it. Okay, you can't just put SSS anymore. SSS, abbreviation was for congruency. Okay, we had with an angle between the two sides. This is only for triangles that this is going to work. Okay, if there's an angle between two sides of a triangle, the triangles are going to be similar. Okay, then we came up here and we said, oh yeah, if you have two angles, okay, then they are going to be similar from one another. This is a little different than congruency. Okay, this one right here had two angles. It didn't need that part right there to get that. And this one right here didn't need that part to get that right there. And this one right over here only needed two of the angles. Obviously, if you have two of the angles equal, the third angle is going to be the same measure anyway. So who cares about the third angle? Once you have two, it's enough to say, let's stop there and let's not make more work of ourselves. If we have two, then the triangles are going to be, okay, similar to one another. Okay, now the one thing that is true right here is, okay, this word, oh, that still does not work, okay, in, okay, similarity, just like it did not work, okay, in congruency. All right, so if we're looking at these two triangles right up here, okay, you can't automatically come up here and say, oh yeah, okay, I don't have the angle, so nope, these aren't similar. They're triangles. Okay, you can use a shortcut right up here. I don't need, okay, to know what these angles are right up here. Okay, so go ahead in your, okay, I'm going to hit pause right now if I haven't already done so, okay, and tell me yes and no and why are these polygons similar. All right, so, okay, this one right over here, if I got the 2 proportional to the 6 as the 5 is proportional to the 10, I want to see, are these sides proportional to one another? Is 2 times 10, okay, equal to 6 times 5? And I can see right now they are not. Okay, so I would say right now, no. Okay, they are not similar because sides are not proportional. Okay, you had to have a set ratio there. If, okay, I would have came up here, and if I would have made this one right here 15, okay, and I would have had then 2 times 15, I would have had 30 equals 30, then I could have said, okay, yes, by side angle side similarity. Okay, but I didn't have a proportion. See, there's the side, there's the angle, there's the side, side, angle, side. I don't really care about that one right there. Okay, if I was trying to go for side, 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 I could, but then I have to prove the other ratios anyway. So this one's faster once I already have an angle. Okay, but you could always try side, side, side. If side, side, side works, then side, angle, side would have worked too. Okay, on this one right over here, are these polygons similar? All right, and you don't have to have anything about the sides on this one. This one's going to be yes by angle, angle, okay, similarity. Okay, all you needed was those 2 angles right there. All right, how about this one right here? Okay, are these 2 polygons, these 2 triangles similar from one another? Okay, on this one right here, okay, you had to come up here and set up a proportion. I have no angles, so I'm going to have to check, okay, are the corresponding sides, okay, that I have up here is 2 over 3 equal to 4 over 6. If I cross multiply, and this is the work I would like you to show to justification. It is not a formal proof. This is an informal way of justifying your proof. So this part right here works. But that right now is only SS. We need one more S. Okay, so I need to check. Okay, and I've already used the 2 and the 3. Is 6 over 9 the same? Is 2 times, when I cross multiply, is 2 times 9 the same as 3 times 6? And, okay, we have a yes there. Okay, so we can say, okay, these things are, okay, similar, okay, by SSS. Remember to put similarity on there. Okay, you can't just put SSS anymore. That deals with triangles. Okay, again, I said right up here, okay, I have some sides. Now the part that I'm looking for right up here is I kind of turned them around. Okay, so go ahead and determine if these polygons right here are similar or not. Type it in if I haven't asked you to do so already. All right, on this one, okay, right over here, okay, what I'm going to do here is I'm going to take, okay, all of these numbers, okay, that I have, okay, right here, and I am going to, okay, turn it. Oh, I thought I was going to get it turned. I didn't have the 5 in there. Okay, but we'll throw, oh, I guess the 5 doesn't want to go with me. Okay, so, okay, we'll put the 5, it rotated down here with it. So now that I have all the numbers matched up, okay, now I need to come up here and I need to see, is the ratio true right here. Is 8 over 10 equal to, I want small over big, I want to go small over big. Okay, is 8 times 5 equal to 10 times 4? And I got 40 equals 40. So I got a yes right there. And, okay, I have an angle right here. So there's the side, there's the angle. So this right here is yes, okay, because of side angle side similarity. Okay, oh, I got polygons here. Now on polygons, okay, tell me if these polygons are going to be similar. All right, on these right here, okay, you have to have, remember, two things. First, look, are all the angles equal? Okay, and that right there, I have a yes. All the angles are. And two, are all the sides proportional? There is no shortcut. I know, pain in the butt. When you see anything bigger than a triangle, there are no shortcuts. Okay, so we have to come up here and we have to do the long method of, all right, is 2 over 3, 2 over 3, is that equal 4 over 6? Okay, cross multiply. 3 times 4 equals 2 times 6. 12 equals 12. So that's one set. Okay, now let's come up here and let's find out about the 8 and the 12. Okay, are they proportional here? And again, I'm going to use my 2 and my 3. They're the smallest ones. I'm going to use the same ratio there when I mean my smallest pair of ratios. 2 and 3, is that the same as 8 and 12? Okay, cross multiply. I have 3 times 8 equals 2 times 12. 24 equals 24. So I'm good there, but don't just say because I have that. Remember, I have this last set, okay, right here, the 6 and the 8, okay, is 2 over 3 equal, I guess it's 6 and 9. 6 and 9, cross multiply, is 2 times 9 equal to 3 times 6, okay, and I get 18 equals 18, and that is a yes. So you have, right up here, are these polygons going to be similar? Okay, yes, because all sides are proportional and all angles are equal. There is no shortcut to this. You've got to write that all out too. Please don't try to do any abbreviating like you do when you're messaging people. Okay, that's about as small as it's going to get when you go to write them. Okay, now, if again I prove, if I give you, okay, that the triangles are similar. If I give you the triangles are similar, we should be able to come up here and find x. So go ahead and do that right now. Okay, when you do this, okay, for tonight, what I'm looking for tonight is that you don't necessarily draw the pictures that I gave you, okay, but as I try to hide things, what I want you to do is I want you to turn this around, okay, so they match up right here. Since they already were matched up, okay, that means A matches up with R. Oh yeah, there we go. I got A matching up with R. B matches up with S. Yep, I got B matching up with S. I got C matching up with Q. Yep, I got those matched up. Okay, so I get them in the right order. And then, okay, I should be able to come up here and say, okay, if 5 is proportional to the upside down 15, 5 to 15, what is x, okay, going to be proportional to? X is proportional to 11. I cross multiply. Okay, and I have 15x equals 11 times 5. 15x equals 55. Okay, and I'm going to come up with x equals, now this part right over here, I'm fine with you leaving it as an improper fraction. Okay, but you do have to reduce it. Okay, so this should be 11 thirds. Now if you want to write down, this is 3 2/3, that is fine, but I don't want 3.6666 repeating. No decimal answers. All right, in conclusion here, okay, when you're trying to prove, okay, triangles or polygons are similar, you need to have two things. All angles have to be equal, and all sides, okay, must be proportional. There are no shortcuts, okay, for polygons bigger than a triangle. However, when we got down to triangles, okay, the first thing I would always look for is the one that's usually pops up the most, and it's the easiest. Look for the two angles rule. If there are two angles in triangles, now remember, this is for triangles, we can use the AA similarity. Now, if they didn't give us two angles and they only gave us one of them, look to see if there's sides on the adjacent to the angle and see if those have the same proportion from one another. If they are, you can use side angle side. But if they didn't give us any angles, this is always the one I test last because it takes the most work, okay, is side angle side similarity. Okay, remember that bad word, SSA never works, okay, and these are the only three that work for similarity. Okay, so again, okay, you were finishing up your map test. If you haven't done so, read section 12.1 and did 1, 2, 9 through 15. You've already watched this ed puzzle here, and now all I'm asking you to do is those two problems. Okay, right there from section, okay, 12.2, number 12 and 13.